We know that A bar is equal to mu by 4 pi ideal e power minus j beta r by r. Just I will disturb about this one. Here real bar is there. You can take in place of ideal bar jdv also. That depends upon the what type of current distribution is there in the conductor. Because we are working for the Hertzian dipole antenna, its length is very small, so that we will take this ideal current instead of JTV. We know that mu by 4 pi is coming in the magnetic fields, similar to 1 by 4 pi epsilon in the electric fields. And the potentials are inversely related to the distance. Potentials are directly proportional to the source ideal. What about this e power minus j beta r? You need to understand that e power minus j beta r has phase beta r. Beta r phase created when distance r is covered. So beta is a radians per meter. R is the distance, that is in meters. So you will get radians. That means beta r is a phase. That is why it is e power minus j beta r is not e power j theta. So when the distance r is covered, the phase produced is beta r. So that we will include that e power minus j beta r in the expression of the A bar. So A bar is equal to mu by 4 pi. Ideal bar is the source. E power minus j beta r is indicating the phase by distance relation is 1 by r. That means by r. Now we assume Hertzian dipole antenna. Dipole means two conductors are there, and a Hertzian dipole means its length is very small compared to lambda. dl is very much smaller compared to lambda, like lambda by 50, like that. So current is almost constant in comparison to lambda, and we assume that current element is available on the z axis. This is x axis, y axis, z axis. So we will take this is the current element to which current I is passing, because it is very small differential length ideal bar. I is a scalar, but ideal is the current element. Is vector. Because of dl bar it became vector. The direction is there. Now we need to calculate the fields at observation point P. Okay. So the distance between observation point and the source point is given by certain distance r. Okay. Then what is the source for A bar? Source for A bar is current, as ideal bar is equal to IDZ bar. Why? It is oriented in the z direction. As ideal bar is along z direction, A bar also in z direction. That means A bar is equal to AZ into Z cap. Only Z component AZ exists. Okay. That means in general, A bar can be written as AXX cap plus AYY cap plus AZZ cap. But in this case, AZ only available. So A bar is equal to AZ into Z cap. Like this we can write. Now that AZ is equal to mu by 4 pi ideal e power minus j beta r by r. But as I said, I need to convert this A bar into spherical coordinate system. That means I need AR, A theta, A phi to write this A bar in the spherical coordinate system. So I need to convert it. So vector conversion we have to use AR, A theta, A phi. The conversion formula we have to write this 3 by 3 matrix into one column matrix, that is AX, AY, AZ. So for conversion, quickly I will revise the things. X, Y, Z, the point is there having the direction of r cap, and it is root theta cap. This is the distance vector theta. So point P, the position vector of point P is making an angle theta with the z axis. So what is the projection of r cap on the z axis? We need angles and projections, that's it. So the angle between r cap and z cap is theta. Then the angle between r cap and xy plane is 90 minus theta, because the angle between xy plane and z axis should be 90. So by adding these two, I'll get 90. When you know the angle between two vectors, then the projection can be written very easily. That is cosine function of that angle. So cosine function of 90 minus theta, that is equal to sine theta. So if you see this matrix, R and Z, 9 values we need actually. So R and Z are related to this particular area, this area. So R and Z are having the projection cos theta. So I'm writing here cos theta. Then the projection of r cap on the xy plane is given by this angle, that is the sine theta. Sine theta is the projection of r cap on the xy plane. But the angle between sine theta and x-axis is nothing but phi. So what will you get? Because angle is phi, the projection is cos phi into sin theta with the x-axis. So with the y-axis means sin phi sin theta, because the sin theta is making angle with the y-axis is 90 minus phi. So you will get cos of 90 minus phi is sin phi. So you can take these things in the matrix now. So sin theta cos phi sin theta sin phi. Okay. Then the angle between z-axis and theta cap is a 90 plus theta. So projection will be cos of 90 plus theta is a minus sin theta. So z and theta means this area, z and theta related to this area, and how much we got now? Minus sin theta. Minus sin theta. Then the angle between theta cap and xy plane is minus 90, because the angle between xy plane and z cap is 90. In order to satisfy that, we need to take a minus theta, and you can see this addition should get 90. Next, so the projection will be projection of theta cap on the xy plane will be cos of minus theta is equal to cos theta. Okay. Then the angle between this cos theta and x-axis is phi. So projection will be cos theta cos phi. And the angle between cos theta and y-axis is 90 minus phi. The projection will be cos theta cos of 90 minus phi. That is cos theta sin phi. Okay. So here I can write now cos theta cos phi cos theta sin phi. Then the third column can be filled from the cylindrical coordinate system and Cartesian coordinate system conversion minus sin phi cos phi 0. So this is the vector conversion from Cartesian to spherical. Once you got this spherical coordinate system, but our AZ is having this, our A bar is having only AZ. So now I am writing like this: AR A theta A phi is equal to sin theta cos phi sin theta sin phi cos theta cos phi sin phi minus sin theta minus sin phi cos phi 0. Our A bar is having only AZ, so 0 0 AZ. You know how to do matrix multiplication. This row, this column, if you multiply, we'll get just AZ cos theta. Then A theta. To get A theta, this second row should be multiplied with this column. So what will you get? Minus AZ sin theta. And what about A5? To get A5, this third row with this column. So you will get 0. That means in this spherical coordinate system, AR R cap plus A theta theta cap plus A Z Z cap. We need 3 components, but here only 2 components are non-zero, last one is 0. So I can write AZ cos theta R cap minus AZ sin theta theta cap. And if phi component is, here phi component is 0. So interestingly, when you write A bar in Cartesian, only one component is there. But if you write the same A bar in spherical, we got 2 components, AR and A theta. You need to concentrate on this one, okay? Then I'm writing now AR as AZ cos theta. AZ is mu by 4 pi ideal e power minus j beta r by r cos theta, and a theta is equal to minus az sin theta minus mu by 4 pi ideal e power minus j beta r by r sin theta. So ar next a theta. Okay. Now, as per procedure, we need to perform the curl operation for a bar to get b bar. That is equal to, in spherical coordinate system, the curl operation formula is 1 by r square sin theta. Take the determinant. Here r cap is there, r theta cap, and then r sin theta phi cap. For the del, we can write dou by dou r, dou by dou theta, and dou by dou phi. And for a bar, we have AR and A theta, but the formula is AR R A theta R sin theta A phi. Now we'll substitute the things. But before writing this one, we have placed our Hertzian dipole at the center of the z-axis. If you move around this one by changing the phi values from 0 to 360 degrees, it is looking same. So, as dipole is symmetrical for all values of phi, so dou by dou phi is equal to 0. So I can make this is equal to 0. Now I am writing a new expression that a bar is equal to 1 by r square sin theta. It is r cap, r theta cap, r sin theta phi cap. Dou by dou r, dou by dou theta, that is 0. And ar is a az cos theta. So I'm writing that one, mu by 4 pi ideal e power minus a theta r by r cos theta minus mu by 4 pi ideal e power minus a theta r by r sin theta, and last one is 0. Now we need to perform this curl operation very carefully. So del cross a bar is equal to 1 by r square sin theta. If you want to get r component, remove this column and this row, then take the determinant of these two, you will get 0. So no r component. Now to get theta component, remove this column, this row, and multiply this one, minus this one, you will get 0. That means no theta component. Now only phi component is existing, that is r sin theta into phi cap. Now perform the determinant for these two. So what will you get? Here to perform this cross product, this determination, minus mu by 4 pi ideal sin theta by r. So b power minus j beta r minus j beta. Like this will get the derivation part. Sorry, here r is there now. But here we forgot one thing. So here I have to write here, that is mu by 4 pi ideal e power minus j beta r by r. Next I need to write here r a theta. So r first I am writing, then a theta is a minus mu by 4 pi ideal by r e power minus j beta r into sin theta, and here you will get cos theta extra, and this is equal to 0. Then if you want to get the r component, remove this column, remove this row, this determinant will be 0. If you want theta component, this one are to be multiplied minus this one, again 0. So 1 by r square sin theta, only phi component will be there, r sin theta phi cap. Then determination of this one with respect to r is to be done. So here this r will be cancelled. Okay, this r and this r will be cancelled. Now the determination will be like this, minus mu by 4 pi ideal sin theta e power minus j beta r, differentiation is e power minus j beta r minus j beta. Then minus determination of this entire thing with respect to theta we have to do. So mu by 4 pi ideal e power minus j beta r cos theta, differentiation with respect to theta is minus sin theta. Then it is equal to this and will be cancelled. Here only 1 by r is there. Phi cap into, I'm writing the common terms, mu by 4 pi ideal sin theta e power minus j beta r, remaining is 1 j beta, and from this part we have r plus mu by 4 pi ideal e power minus j beta r sin theta is taken outside. Here 1 by r is there, and from the outside 1 more 1 by r is coming. So we can tell it is deltas a bar, that is equal to b bar, that is equal to mu h bar, that is equal to mu by 4 pi ideal sin theta e power minus j beta r, j beta by r plus r 1 by r square. So mu and mu will be cancelled. So h bar is equal to h phi phi cap into phi cap, that is equal to r h phi is equal simply mu by 1 by 4 pi ideal sin theta e power minus j beta r into j beta by r plus 1 by r square. Now we will see in the remaining part of the analysis of the antenna, that is to get the electric field. We know that del cross h is equal to j omega epsilon into e bar in free space. So we need to perform curl operation for the h. So del cross h bar is equal to 1 by r square sin theta r cap r theta cap r sin theta phi cap. Do by do r, do by do theta. Here do by do phi again with the similar Bayesian we can take 0, no changes with respect to phi. Next here we have to write actually hr r h theta r sin theta h phi, but we have only h phi component in the h bar, so I'm removing these two 0 0. Now I will substitute here h phi. So it is equal to 1 by r square sin theta r cap r theta cap r sin theta phi cap do by do r, it is do by do theta 0 0 0. What is this one? R sin theta is coming from the formula, and h phi is ideal sin theta e power minus j beta r by 4 pi, and here j beta by r plus 1 by r square. You can check ideal sin theta e power minus j beta r by 4 pi into j beta by r plus 1 by r square. We can close this determinant. Now this r you can multiply inside. Okay, this r you can multiply inside, then what will get? So this will be gone, here this r will be gone, here this square will be gone. Okay, then we perform this determinant. When you want this r component, remove this column, remove this row. So this is to be differentiated with respect to theta, and then these two anyhow 0. So r component is existing. What about theta component? Remove this column, remove this row. You need to differentiate this one with respect to r. That is also valid. And when you want to get phi component, remove this column, remove this row, here zeros are there. That means now itself we can tell the cross product, the curl operation of h bar is having, that means electric field can have only r component and theta component. Okay, it cannot have the phi component. Now we'll do that one. It is equal to 1 by r square sin theta r cap into this one we have to do. It is sin square theta. So r cap into perform the differentiation of this one with respect to theta. First I am writing all constants, that is ideal e power minus j beta r by 4 pi into j beta plus 1 by r. Now it is sin square theta. Sin theta, sin theta, sin square theta. Perform the differentiation with respect to theta. So what we'll get? Sin square theta means 2 sin theta cos theta. So 1 is over. Now close the bracket. Put minus r into theta cap. Open the bracket. Now remove this column, remove this row, perform the differentiation of this one with respect to r. So I'm writing the constants first. Ideal sin square theta by 4 pi j beta is constant. Now what is there in the first term? E power minus j beta r. So differentiation will be minus j beta e power minus j beta r over. Okay, then next term will be e power minus j beta r by r. So what will be the differentiation? U by v formula we have to play by v square, that means by r square. In the numerator v into, that means r into differentiation of e power minus j beta r, then minus j beta will get minus u, that means e power minus j beta r into differentiation of the v, that means the differentiation of r is 1. So in this manner we have written. Then it is equal to, now what I am doing is I am sending this 1 by r square sin theta inside. So we'll see what will happen. R cap ideal e power minus j beta r by 4 pi. This sin theta will be cancelled. So only in the numerator we play with the 2 cos theta. What about this r square? This r square is going to this area. Then we will get j beta by r square plus 1 by r cube. This is about r component. Now we'll apply this one to this part. The two terms are there, so be careful. So here you can see minus into minus will be plus. Here also minus is there, this minus will be plus, so everything is plus, no problem. So plus theta cap ideal sin square theta by 4 pi, minus is already gone, j square vq1 minus beta square e power minus j beta r. But this is to be divided with this is to be divided with r square sin theta. Here also theta cap ideal sin square theta by 4 pi. This is what we have. Here r is there, no? This r square. So we'll get in the denominator only one r. One r we will get. And here sin theta is there. Here sin square theta is there. So we can remove this square. Now this is what we got, the first term. Okay. Then we'll see the second term. So here in the second term, we have again theta cap only. And ideal sin theta is there. By 4 pi is also there. Now I'm taking this part is common. So what we'll get? Now this 1 by sin theta term is already covered. 1 by r square is there. So 1 by r is coming with respect to this r. So 1 by r is coming to this area. That 1 by r, this r will be cancelled. Okay. And e power minus j beta r is already sent outside. So what will you get here? J beta by R square. You will get here J beta by R square. Okay. 1 by R is coming actually. Next, since 1 by R is coming, here you will get plus 1 by R cube. Anyhow, here e power minus j beta r, e power minus j beta r is available. So finally, del cross h bar is equal to, we got r cap into ideal e power minus j beta r 2 cos theta by 4 pi. It is j beta by r square plus 1 by r cube plus theta cap into ideal sin theta by 4 pi into e power minus j beta r minus beta square by r plus j beta by r square plus 1 by r cube. Like this we can get. Now this is equal to j omega epsilon into e bar. So how to write now? E bar is equal to, you need to divide this expression with j omega epsilon. So r cap into ideal e power minus j beta r into 2 cos theta by 4 pi omega epsilon beta by r square minus j by r cube plus theta cap into ideal sin theta by 4 pi omega epsilon e power minus j beta r into, it is 1 by j, that will minus j, that means plus j, beta square by r, j will be cancelled, beta by r square, and here 1 by j is minus j by r cube. We get j beta square plus beta by r square minus, yes, correct. So in this manner we will be having the e bar.